In this episode, we will talk about the Walker catalytic converters and their essential role in the containment and transformation of the dangerous, harmful gases produced by the combustion engines of our automobiles before they go out to the atmosphere. Walker, with 63 manufacturing plants distributed throughout the world and 8 engineering technical centers, is one of the largest emission control manufacturers, both for the original equipment and the aftermarket. Walker is also one of the pioneering companies in the development of DPF particle filter systems for passenger vehicles to guarantee the maximum level of engine performance with the minimum consumption. Walker takes special care of the level of back pressure and noise of its products, homologating them following the strictest environmental regulations. A catalyst is a unit of the vehicle emissions control system that serves to transform the harmful emissions of carbon monoxide, unburned hydrocarbons, and nitrogen oxides emitted by the internal combustion engines of our vehicles in others as carbon dioxide, water, and molecular nitrogen, considered harmless to the environment. The internal structure of a catalytic converter is quite simple, consisting of the following parts: the pipes and connections to install it in the exhaust system, 1 or 2 protective housings made of stainless steel or BHT, a thermal insulation layer installed to keep the internal monolith working at the correct temperature and prevent it from cooling suddenly, the expandable thermal layer, which is usually made of mineral material that expands with temperature and whose function is to fill the possible gaps that appear between the internal housing made of metal and the monolith made of cordierite due to its different thermal expansion coefficients. When submitted to high temperature, the size of the metal expands to more than the size of the ceramic monolith, and that gap is filled by the expandable thermal layer, which keeps the monolith fixed, preventing it from being hit and damaged. The internal monolith can be made of ceramic material or stainless steel, depending on the design and specifications of the catalytic converter manufacturer. It is important to know that the vast majority of the catalytic converter monoliths, both in original equipment and aftermarket, are made of ceramics because they last longer active and are easier and cheaper to produce. For these catalysts to work, there must be 3 fundamental premises. The first one is that the catalyst has the minimum amount of precious metals needed to perform the oxidation and reduction of chemical reactions within the monolith. The second is that the minimum catalyst activation temperature is reached, which in most modern catalysts is estimated to be around 270 degrees Celsius. The third is that the air-to-fuel mixture ratio is at the right level. The catalysts can be divided into 2 large groups. In the first group are the type-approved catalysts, also called homologated. These are the ones that are designed for a specific car model and therefore being the right option for the vehicle in terms of performance, consumption, and protection against other engine failures. To obtain the homologation documents, these parts need to pass a series of strict and mandatory governmental technical tests to prove that their design will not affect in any negative way the performance and consumption of vehicles compared to the original equipment part. In the second group, on the contrary, are the so-called universal catalytic converters, designed and manufactured to cover a range of vehicles from different engine sizes, and therefore necessarily different from the original equipment designs in terms of back pressure and performance. It is important to remember that the installation of universal silencers, catalysts, particle filters, and SCR catalysts are considered illegal in the European Economic Community for not complying with the minimum requirements of precious metals, performance, and back pressure necessary to ensure the right level of performance of the engine and the emission control system of our vehicles. Due to this situation, it is illegal to install them in vehicles, and if they are detected in the periodic technical inspections in MOT centers, they can be rejected and forced to replace them by homologated units. Due to the high cost of these systems and the risk of damaging other vital systems of the vehicle if those units are not performing as designed by the original equipment manufacturer, Nowadays, the homologation becomes more important than ever for all the parts of the emission control system: silencers, catalysts, particle filters, and selective reduction catalyst systems. For this reason, for more than 2 decades, Walker has homologated all its emission control products, such as silencers, catalysts, particle filters, and SCR catalysts, fulfilling the strictest international requirements. The most important factor in the design of any of the units of the exhaust system is its level of back pressure, since the slightest variation of back pressure with respect to the parameters for which the engine was designed would produce a loss of unburnt fuel that would end up burning on the surface of the catalyst. The fuel burns at approximately 1840 degrees Celsius, while the catalyst monolith melts at 1400 degrees Celsius if it is made of cordierite, and at 1600 degrees Celsius if it is made of metal. Therefore, it is easy to see that this type of problem always ends up melting the catalyst, with a costly repair for the drivers. One of the safest ways to avoid these types of problems is to only buy homologated silencers, catalysts, particle filters, and SCR catalysts, and in case of doubt, request the homologation certificate to your supplier. The reactions that take place inside the catalyst can be divided into 2 types. The first type are the oxidation reactions, in which oxygen is added to some harmful molecules, as in the case of carbon monoxide and unburned hydrocarbons, to transform them into carbon dioxide and water, both considered harmless molecules, thanks to the action of oxygen. These reactions are exothermal. That means that when these reactions take place, the temperature of the gases increases downstream the catalyst. The second type are the so-called reduction reactions, in which the oxygen is removed from the harmful molecules, as in the case of nitrogen oxides that are transformed into carbon dioxide and molecular nitrogen, both considered harmless molecules by the action of carbon monoxide.
We are Garage Gurus. Join our community. Follow us on social media. Thanks for watching this video. The video description contains all the relevant links. Don't hesitate to like, subscribe, and be notified when we post new content. Also, check out our Garage Gurus online course catalog.